Alrighty. If the PowerPoint is correctly placed, then this is where we were. So identifiers. What identifiers are the names that you get to pick for stuff in the language in your program. Variable names are the ones you'll make the most often. Also, method names. Methods are functions in other languages. We call them functions in Python. If you took C++, then we call them function up until a certain point of the class. And then lastly, class names. So some rules. They can be letters, uppercase and lowercase, A through Z, plus some Romanian and kanji characters and, whatever other language you can manage to type in. If you have a Korean keyboard, great, Also the digits and underscores and dollar signs. Are you going to use dollar signs? Probably not. Not recommended to use dollar signs. But they work. I believe they work. We'll find out in a minute. I believe that's what the slide says. Yeah, you can use dollar signs and underscores. The only critical key here is that the first letter can't be a digit. Let's rewrite that. First character cannot be a digit. No spaces. These are the only special symbols you can put. You can't put commas, periods, whatever. So which of these are valid variable names and which are not? All right, just going from the top to the bottom and nudging this over so it's not off the screen. Wish the projector would be fixed. Here we go. Is that a good, is that a valid variable name?
Yes.
Yeah, you can do A is equal to 100 or something like that. Is it a great variable name? No, you should avoid single letter variable names because you want to give good variable names that convey meaningful information. The only exception would be for loops. On the other hand, when I'm typing code up here, I will quite often just use single letters because I'm just conveying some mathematical concept or something. If I'm doing x is equal to 1 plus 2, I'm not going to take the time to come up with a great name for x. So anyways, so rules, you can have the letters, you can have digits, you can have those two symbols. The first character can't be a digit, no spaces, and then guidelines. We have guidelines, recommendations, conventions, which are no single letter variable names except for loop counters. And like I said, you'll see me disobey that, but think scornful thoughts at me whenever you see me do that. Okay, then variables should begin with a lowercase letter. So should methods. Class names should begin with an uppercase letter. And whenever we make some code, whenever we make a new project, we'll see that it's kind of obeying by that. So I'm going to make a new file, and I'm just going to call it September 7. It did abide by all those rules. Here's our class name. It put an uppercase S there. Here's a method name. It put a lowercase m to start with. Args started with a lowercase a. Now, is the code going to break if you start your class with a lowercase letter or you start your variables in an uppercase letter or anything like that? No, it's not going to work. These are conventions. What does that mean? It means that these are practices that are followed by tens of thousands of other programmers. So, especially Java programmers. Here's another one. Rather than use underscores, it's better. I'm going to put the word better in quotes because I kind of like underscores. to use what's known as camel case. Camel case is when you capitalize new letters, like patient temperature, tax rate in Oklahoma. Valid data. Stuff like that. Now to me, if you use underscores, and if you typed in patient underscore temperature, and you typed tax rate underscore in underscore Oklahoma, and you typed valid underscore data, those to me look easier to read. But they're out of favor. C programmers used underscores, Java programmers use camel case. It seems to be the rule. So is this a valid variable name? That one right there. Is that good or bad? Thumbs up or down?
Good.
It's good. It's a good variable name. Nothing wrong with it. How about that?
No.
Nope. Bad. How about that one? Nope. It's bad. It's because it's got two words. How about that one? Good. Has underscores in it, which some people would, throw shade on you for that. And then that one, sure, that's good. So more rules. Back up here. Case matters. X is not the same as X. Just got to be careful about that. A lot of times people are writing in code and they'll say age is equal to 10, and then later on they'll do system.out.println age with a capital A. Whatever. Real easy to do. You just got to find it and correct it. It won't run until you fix that. So to declare a variable, you give it a data type followed by the name. Int space student ID. Int space row, comma, column. So you can define more than one variable at a time as long as you separate it by commas. You could do int x, comma, y, comma, z. That works, or string first name, comma, last name. There's a reason why I prefer to not define multiple variables on the same line unless it just looks better that way. And I'll show you what I mean. If I had this, int x, comma, y, comma, z, and I put a comment out here that meant, coordinates in space, something like that. That'd be clear enough, right? I wouldn't really feel the need to do this, int x, int y, int z. On the other hand, if I'm doing something like this, double principal, comma, no, I'm not going to even give good variable names. PRINRT in, you don't know what those things are. Most likely. You don't know what I'm thinking of. And yes, I could give better names. But if I wasn't going to give better names, here's how I would do it. I would go ahead and put each one on their own line, and then I'd put a comment after each one saying what they were. PR would be principal amount. Interest would be interest earned. RT, interest rate. And then N is compound how many times a year. Right? That way I'm explaining what the variables do. So if I need to explain what the variables do, I'm not going to just list them all in one fell swoop like that. If I don't need to list what the variables do because they're all very clearly named or they're all very closely related to each other, like x, y, and z coordinates, then it's okay to go ahead and list them like that. It's a stylistic matter. Your goal is to make your code as readable as possible. That doesn't mean going overboard and adding a comment to every single line of code that you write. But certainly, putting a comment saying what a variable is used for is a good practice. Now, I may not do that all the time, because the more typing I do up here, including comments, the faster and harder y'all have to type to try to keep up. So, I don't necessarily comment my code up here enough. I try to do it enough that I'm being a good example for y'all. Assignment statements. The assignment operator is the equal sign. It differs from equal equal. You'll see both of them in your code. A single equal means that you're copying a value. 50,000 gets copied into salary. The word bonus plus $sign gets copied into bonus message. That's why it's called assignment. You're assigning a value to it, just like you give an assignment to somebody, they have to go do it. Here, there is no value being assigned to it. We're going to assume that later on, somewhere further down the, well, as a matter of fact, right here, we declare our variable, we declare this variable, and then we assign a value to that variable, and then we assign another value to that variable at the same time. You could do both at the same time. You could do int salary is equal to 50,000. If you do that, you don't need that line. Right? Because this is called initializing. If you initialize a variable, it means assign it a value right when you declare it. So let's define those terms. Declare a variable is to give it a type. Int max value. Assign a value is to copy a value into the variable. Max value equals 100. And then int max value equals 100. That's to initialize a variable. Equals to declare and assign in one statement. Some people like to do things like this. Int x is equal, or int x, y, z, and then they do x is equal to y is equal to z is equal to 0. Would that work? And the answer is yes, because the equal sign is resolved. The assignment operator is resolved from right to left, meaning it has right associativity. So this is the first thing that happens. And then that gets copied into here. And then that gets copied into here. So it's kind of like it was written like this. Are you going to write it like this? No, absolutely not. That's silly. But that's what that does. Or you could do it like this. That's one possibility. Or you could do int a is equal to 0, b is equal to 0, c is equal to 0. Why are we bothering to put values in here? Because until a variable is initialized, until a variable has a value, you can't use it. If I did this, int name, no, not int name, string name, and then I did system.out.println name, that's an error because there is no data inside name. If you do int x, comma y, and then later on you do int product is equal to x times y, that's an error. You don't have any values here. So when you declare your variable, you can go ahead and give it an initial value like that. Just so that you won't get any variable has not been initialized errors, which you would otherwise. If I went in here and I typed in one of those things, don't know why I'm getting a little happy circle. All right. So int x comma y, and then I did int product is equal to x times y. It's going to give me little red messages here. Variable x may not have been initialized. Well, you're darn right, because I don't have any values in it, huh? So I could initialize here if I think that it's a good idea so that I don't get that error message. Now this editor here has a strange little quirk. It doesn't like you to initialize values if the value doesn't actually get used. And what does that mean? If I later on turn around and give x a different value, you can't see it because it's in yellow, but it underlined this 0 right here. And it popped up a little error that it said the assigned value is never used. Okay, yeah, great. I know it's never used. I don't care if it's never used, but it wants to warn me about it. So if I want to make that warning go away, I then have to remove it. So is it a great idea to initialize a value every single time you declare a variable? Just do it if it makes sense. Don't do it as a matter of habit. Because that is actually some useful information, this error down here. Y may not have been initialized. Then it leads you to think, oh, well, why doesn't Y have a value? Oh, yeah, I forgot to ask the user for Y. Or, oh, yeah, I forgot to call a function that would give me the value of Y. So these errors are actually useful information which is just hidden a little bit by initializing your data up there. So my recommendation is to not go and just give x equals 0, y equals 0, initializing everything as you declare it. Oopsie. Don't know why we have this on top of here. Oh, because I changed. I did that. Okay, the plus sign means two different things in two different contexts. If one of the items on either side of the plus sign is what's known as an operator, just like minus and multiplication and division. If you have two numbers, one on either side of it, then it does math. But if one of them is a string, it does concatenation. What's the difference? Well, concatenation is just when you take two things and glue them together. Let's give an example of that. Go ahead. I hope you have NetBeans open. If you don't, it's okay. We haven't typed in anything that's that useful. But if we did this, string S1 is equal to 22. And then we did string S2 is equal to 33. And then we did string result is equal to S1 plus S2. If we print this out, what is it going to print? Is it going to print what 22 plus 33 is? Is it going to print 55? No, it's going to print 2233 because these are strings. Strings are not numbers. They're not mathematical values. So they don't get added, they get concatenated, meaning they get appended onto it. So this gives us 2233, not 55. If you print that out, we can print it out just to make sure. System.out.println result, we'll see that it says 2233. So what does that mean? It means that if you have a number and you need to do math with it, you have to convert it if it's stored in a string. If you have a string that contains a number, the computer doesn't know that it's a number until you actually convert it. You Python users, remember that the first thing we did anytime we got any input is that we called the int function or the float function to turn it into a number. We may not be doing that kind of thing as often in this class, but the concept is still the same. You can't do any math with a string. You have to convert it into a digit form, either a floating point, or an integer form in order to do math with it. So, plus is the addition operator when it is between numeric values. Plus is the concatenation operator when it is between a string and another value. Maybe that sounds kind of weaselly, a string and another value. Why not? Why doesn't it have to be two strings? You'd think it would have to be, right? If you did this, string S is equal to hello plus 3. That kind of looks like an error to me. You can't add 3 to hello. Well, Java assumes that if you try to add something to a string, it needs to be converted to a string. So what this would result in would be the string hello 3, like that. And we'll see that a lot. Java will convert values from one to another if it thinks that it's a good idea to do so. And that sounds vague, but we'll hammer on much more specifically when it's okay for Java to do the conversion, and then when you have to do the conversion yourself. And specifically, Java is happy to convert a primitive value, a number, into a string so that they can be concatenated, but it will not convert a string to a number. You have to do that yourself if you see the need to do so. I am pretty sure we did a hand tracing of a program, did we not? All right, ints and longs, we've talked about them. Ints go up to 2 billion, longs go up to 2 supercentillion, whatever, 9 to the power of times 10 to the power of 18. So if you're reasonably sure that your value is never going to exceed the millions, you may as well just use an int. But if you think it's going to get larger than that, go ahead and use a long.
If long can produce if long can have more numbers, why does things even exist?
Good question.
I'm not being
I don't know. No, I'm totally serious when I say I don't know why people don't just use the largest data type reasonable. And in one case, Java did make that decision. Float versus double. Double is the default type for Java, even though it takes up twice as many bytes as a float. If you feel like using long throughout your code, I certainly am not going to look askance at you. On the other hand, if another programmer comes in and wonders why you're using a long to hold the length of a name or something like that, they're going to go, well, that's silly. It's okay with me if you do it. Does that make sense? No, it probably doesn't, because I don't have a good reason for why you wouldn't just use long all the time, except that people are going to kind of look at you odd.
Yeah, earlier you said something about people throwing shade. Is there a lot of that in programming?
Well, if you work with a team of people, your code will probably go through code review after you've written a module, so that other people look at it and they make sure that it's going to behave the way that it's supposed to work. And the reason they do that is so that when you ship it to the customer, it has a good chance of actually working. And there may be company guidelines that you're expected to follow. Your code needs to work this way. It needs to be commented this way. That kind of, shade, making fun of each other and stuff like that would just be like if you're friends with the other programmers and stuff like that. It'd be really tacky to get aggressive, on somebody outside of that. So assignment between different types. You can assign a value into a type that is not strictly a match for it. You see that? That's an int. But this is a double, so it's a floating point value. And I think I have said before that Java is a strongly typed language, also known as strictly typed. Different people use the same terms. Meaning that once a variable is declared, it can only hold data of that type. So if you do this double D, all D can hold is a double. Does that mean that it can't hold an int? It can't hold a float? Yeah, it kind of does, but Java will do the conversion for you if it's safe for it to do so. If you do this, int x is equal to 100, and then you do d is equal to x, double d is equal to x, that's not an error. Why? Because an int can fit just fine inside of a double. No problems at all. It can be promoted safely. There's a hierarchy of data types. And promotions, automatic conversions from one to the other, are safe. Ints can go into longs just fine. Longs, ints can go into floats just fine. Longs can go into floats just fine. Floats can go into doubles just fine. Everything can go into a double just fine. But you can't go reverse. If you try to do this, double d2 is equal to 100.0, and then you try to do int x2 is equal to d2. In this language, unlike C++, that's an error. C++ goes, okay, well, I guess I'll just round it down. No problem. Java won't do that automatically. It will not go from a higher capacity data type to a lower one. A double will not fit into an int. For one thing, you might have fractional data, 50.5. What's it going to do with the 0.5? On others, it might be a huge number. It might be 3, quadzillion. And that's not going to fit into an int, which only holds up to 2 billion. So it will not automatically do those things. You can tell it, no, I really, really want you to do it, and it's my fault if this doesn't work. This is known as casting. If you do this, int x2 is equal to an integer version of d2. This tells the compiler, yeah, it's okay. Go ahead and format it as an int so that we can store it into here. And if it doesn't fit, well, too bad. It's our own fault for thinking that it would. It's not the compiler's fault. The compiler tried to stop us. It gave us an error when we tried to compile that code. So when we added that to it, yeah, sure, now the d2 does get converted into an int, meaning that it gets rounded down, and if it's too many bits long, the value gets truncated in some weird way. That some weird way sounds kind of nebulous, doesn't it? But if you're absolutely sure that d2 is a pretty small value, and that it can be safely converted into an int without significant loss of data, and that's what you want to do, you can do that. So casting converts from one data type to another. Use it to convert between types that the Java compiler won't otherwise do. Java tries to forbid lossy conversion. Lossy conversion is when you could lose data. An int is tiny. It'll fit into a long just fine. A float is tiny. It'll fit into a double just fine. That's lossless conversion. That's totally okay for it. It won't give it, the compiler doesn't note it. It doesn't put any red marks on it. It's just totally safe. Going the other way, though, it'll flag as an error, and you have to fix it before you go on. If you try to put a long inside an int, it knows that it won't fit, and that some data might get lost, and it makes you make the decision that you really want it to do. And so you have to go in and you have to add that keyword there to go to an int. You can use other data types. If you want to take an int and turn it into a float, you would put float there. Or if you got to convert something into a long, you can do that. So here we go. Float f2 is equal to the floating point version of d2. If for some reason you wanted to store it in a fewer number of bytes, I can't think of why. I've never done this. But you could. You can convert it to a floating point number like that. And again, you are taking responsibility as a programmer that if d2, if this double was too large to fit into it, and so the data was mangled, truncated in some form, and the number was not valid after that. And we can, well, let's find out. I don't recall us doing this particular exercise. Let's do a little bit of casting. So we're going to do double D is equal to, and we're going to type in a pretty big number, 999, followed by, I don't know, a whole bunch of zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9 zeros. So that's 999 trillion. Now it doesn't like me typing that in because this is a literal, and literals are assumed to be integers, and that's too big to store as an int. I could tack on an L there. That might clean it up. Or maybe if I tack on a 0.0, which will convince it that no, that wasn't an integer. So there we go. Now, let's get an int going. Int I is equal to D. Is that going to work? No. It says it's an error. Incompatible types, possible lossy conversion from double to int. We can fix that. We can say, no, I really did want to see it as an int. So let's print those two things out. System.out.println D equals, end quote, plus D. And then system.out.println I equals, end quote, plus I. And there we go. D is equal to 9.99 exponent to the 11, which is the value that we gave it. But I, when we tried to convert that into that is equal to 2 billion and something, 2 billion and change. Obviously, some data was lost. Obviously, the result is not valid. But if this number had been small enough to fit in here, it would have been okay. Like, let's just make it 9 million. Go back up and edit that 9 trillion to be 9 followed by 6 zeros, which is a million. 9, 1, 2, 3, 4, 5, 6. So when I print it out, our double is equal to 9 million, and so is our I. It did comfortably fit. Just up to you to know, oh, that number's going to fit. Or, think of the ramifications. On the other hand, if you can do all your math with doubles, why would you convert it to an int? There may be times when you need to round it, to a specific value. If you were going to do that, I'd round it to a long, not to an int. You can do the same thing. Let's do that. Let's do long. I'm going to use a capital L. L is equal to the long version of that D variable. And then let's print that one out. I did capital L just because it otherwise looks like a 1. System.out.println L equals, end quote, plus capital L. And we run it, and yeah, I's, L are the same thing because 9 million comfortably fits in both an int, which is a 4-byte data type. It holds 32 bytes. And the long, which is an 8-byte data type. It's got 64 bits. Okay, we're going to make this number too large again. So I'm going to delete that. I'm going to go back up to 9 trillion. 9 followed by, or even 9 billion would do it. 1, 2, 3, 4, 5, 6, 7, 8, 9.0. Okay, so that's 9 billion. That's too large to fit into an int, but it'll fit comfortably into a long. So if I run it, I'll see that, yeah, it got corrupted when it was stored into an int, but it fit just fine into a long because the maximum value of a long is far larger. All right, I think that making sense. I don't want to belabor that. Just want y'all to have the idea of casting. The other way is just fine. If you want to do this, long is equal to I, even though this is an int and it's not the exact same data type, it's easily converted to it. It's a lossless conversion. There's no risk in doing that. If you want to do D is equal to L, again, a double can hold a long just fine. So it doesn't flag that as an error. We don't have to do any casting. So assignment between different data types. Putting a floating point value into an integer is like putting a large object into a small box. It's illegal. This generates a compilation error. You can't assign that to that. Even if it looks valid, right? Int count is equal to 0.0. Well, it's a whole number, isn't it? No, this is a floating point number. It's a literal that's encoded into your code, hard-coded into your code. It's got a decimal there. So the compiler says, oh, that's a double. And then it's trying to copy a double into that, and it's not going to let you do it. Constants. Constants are fixed values. They're numbers that should not change. You can make your own named constants if you need to by using a special keyword. And by default, every number you type is already a constant. Is that 9 billion going to change somehow magically without you coming in and typing a new value by hand on top of it? Nah. It's just numbers. How could it change? So that's what's known as an unnamed constant. If you want to make a variable which is a named constant, which you're kind of writing a contract, an agreement saying that this variable can never change in your program, you do it with a keyword. Other languages use const. This one uses a word final. The final version of pi is equal to 3.14159. It's obviously, whoops, I forgot to give it a data type. Final double pi is equal to 3.4159. I know I said that wrong, but you get the idea. That means that if later on, if I think that I can change the value of pi plus equals 1, No, I can't. That's an error. The compiler will not compile it. It says cannot assign a value to final variable pi. So when you're coding in a group environment, you have multiple programmers working on your code. If you have values that shouldn't change, and if it would break the code if it was changed, you go ahead and define them as constants so that they can't be redefined. If I had that word final there, and I took that word away, and then some idiot thought that it was okay to change the value of pi, then the rest of the code that used that value of pi would be wrong. So if you have numbers that should not change throughout your program, go ahead and make them final. A named constant is one where you give the variable a name. Notice that this textbook always does named constants in uppercase letters, separated by underscores. Hey, there's my good friend the underscores back. Somebody decided that constants should be named in uppercase with underscores to make them easy to read, easy to spot. That's a visual indicator that in your code, what you're looking at is a constant that should not be changed, or maybe cannot be changed. So if you were looking at some code down here and it said pounds is equal to kilograms times kg conversion ratio, you would know that somewhere up above there had been defined kg conversion ratio, and since it's all in uppercase and it has those things, those underscores in it, you better not try to change it. Even if you could get away with it, it's not supposed to be changed. It's just a visual indicator. So we're going to go back to our guidelines up here for variable declarations. But you do use underscores when defining constants. Example, speed of light. Constants should be named with all caps and underscores. Am I going to count you off if you do it differently? Nah. It's just conventions. Your code's going to look more professional. Other programmers will understand it, understand your purpose, because everybody's being taught the same thing in programming school. And once you get in the real world and you're looking at a lot of other code, you'll see a lot of times when it meets these recommendations, and then you'll see a lot of times when it doesn't. It's okay either way. Two benefits of using named constants rather than just hard coding numbers. Using named constants leads the code to be more understandable. And if a programmer ever needs to change a named constant's value, the change is easy. I'll give you an example of that. Say we have in our code, and you don't have to type this because, well, like you see that already being an error, 2.2. And then somewhere else I use that conversion ratio. I said x is equal to y divided by 2.2. And then later on I use that somewhere else. I said that patient weight is equal to z times 2.2, whatever. Somebody may not know what that 2.2 means, right? They're going to open up the code and look at it. It happens to be an approximation of the kilogram to pounds conversion ratio, but it's not precise. And it's not such a common number that everybody who looks at it is going to instantly know that's what's going on, some conversion between kilograms and pounds. So then somebody tells you, no, we're getting the wrong answer here. And you say, what? And they said, well, this should have been 77.3 kilograms, and instead it says 77.215. You go, really? You care that much? So you look it up and you find out the exact conversion ratio, which 1 kilogram in pounds, I think it's 2.204. Okay, there it is. That's the exact ratio. So you decide, I'm going to make my code better, and I'm going to go in and I'm going to fix that. Ta-da, I'm done. Are you done? No, because you use the same number here further down in your code. And you use the same number down here, maybe in a completely different file. If you had defined that up here, final double is kg conversion is equal to that, and then everywhere you needed it, like here, and here, and here, wherever that other third one was, then if you ever had to change the value of it, it would work. It would change it everywhere, like a tax rate. You write a program for your brother, and then the tax, he moves to a different city, and the tax and the local sales tax is different. You don't want to have to go through your code and change, 8.75 to 9.3 in 100 different places in your code. Really, that kind of stuff should be stored in an initialization file or something, right, in settings, so that it can just be changed once. But at the very least, you want to define it. Putting numbers, hard coding numbers, into your equations, into your formulas, is generally very frowned upon because it's not as easy to maintain. And when you're looking at it, you don't know what that 2.2 is. So you will see things like speed of light and kilogram conversion and pi and stuff like that defined. And when I give examples and when I give you formulas for assignments, I may not tell you to do that. I may just give you the formula for converting inches to centimeters or something like that. And I may not say, define this as a ratio. Make it a constant. Use the word final. But if you think to do it, go ahead and do it. You'll impress me. Never know when I'll actually give you, a couple extra points for doing something like that, for adhering to coding standards above and beyond the absolute minimum. So 2 reasons to use the named constants rather than hard code the literals. The code's more understandable. When you see x times kilogram conversion, you know what it's doing. And then if you ever need to change the value, the change is easy. You find the named constant and you just change it once and it works through the entire code base. So arithmetic operators, we know how addition and subtraction and multiplication work. Division is a little bit different because it differs its behavior based on its operands. So we got to define operands and operators. And you 1113 students already know. Addition, subtraction, multiplication, and division are operators, and the operands are the data that is on either side of the operator that the operators work on. So if you have x plus y, plus is the addition operator, x and y are operands. There's no magic to the way plus works, to the way minus works, and the way multiplication works. However, division behaves very differently based on whether its operands are integers or not. If you do this, x or double d is equal to 4 divided by 3. What's d going to be equal to? 1.333333? And then you do double x is equal to 1 divided by 2. What's x going to be? Is x equal to 0.5? It is not. Is this equal to 1.3333? It is not. Since both operands are integers, it switches the behavior of division, and it doesn't do floating point division like you would get on a calculator. It instead does integer division. And integer division rounds down. So 4 divided by 3 is 1.333, but then it rounds it down. So even though this is a double, even though it could comfortably hold 1.333 out to 20 places or whatever, it turns out that that evaluates to 1.0. Why? Because the right-hand side gets done first before it ever gets copied over here. So it doesn't know whether it's copying it in advance. It doesn't in advance know what's happening on this side. It just does this side first, it gets that value, and then that gets assigned over here. And great, it's a double. It doesn't care, it's fine. It's still going to be 1. It got rounded down. Just like this, 1 divided by 2 is 0.5, but that rounds down and then it gets copied into x. So no, that's equal to 0. I could give you an equation, an assignment where you were going to calculate pi, where you were going to approximate pi via a series formula. And if I did that, then I might tell you that the formula is 1 divided by 2 minus 1 over 3 plus 1 over 4 minus 1 over 5 or whatever, but it wouldn't work. It wouldn't give you the right answer because that would be doing integer division and would be rounding all that stuff down. So that's important enough that I'm going to make a real big point of it right here. Be careful. If both operands of division are ints, then the operator does integer division, which rounds down. Python guys, remember that we had two different divisions, right? You could do this. A is equal to 4 divided by 3. And if you did that, A would equal 1.333. And then you had floor division. A is equal to 4 divided by 3 with 2 slashes. Floor division would round it down to 1. Don't have the choice there. We don't have floor division. We just have a single slash, which the compiler decides which one we mean based on whether it's surrounded by ints or not. But if one of the operands is a floating point type, then it works. So if you want to do this, double D is equal to x divided by 2, it's better to make it divided by 2.0 because then you don't have to worry about x being an integer and it rounding it down. If you make it 0.0, it forces floating point division to happen, meaning that if it really was supposed to be 3.5, it wouldn't round it down to 3. So if you can remember to, anytime you're going to divide by a constant like that, go ahead and turn that constant into a floating point number. Go ahead and add the 0.0. Even if it doesn't look like you need to, that just ensures that you're getting floating point division done. That can creep up into some real errors. So if we did this, double D is equal to x divided by 2. If x was an int, this would round down. If x was a floating point type, it wouldn't. To be sure that no rounding occurs, just divide by 2.0 instead.
If they were coming from like inputs, could you just label them as floats instead of double, and then it just take care of the rest, right? Even if they put in.
Right. If you store everything in a double, then you're never going to get that rounding error. Right. If all your variables are double, but if you have reason to use ints, like your floating point math is imprecise. It gets rounding errors, which sounds stupid, but I could give you some examples of it. Let's see if we can find one. I'm sure we have syntax errors here now. I'm going to have to come and delete them all. Instead of just letting me take random guesses at it, let me go find one. Floating point error or rounding error, Java example. There we go. Y'all go ahead and type this with me, just for grins. T1 is equal to 0.7. Double T2 is equal to 0.9. And then T1 is equal to T1 plus 0.1. That's going to take that 0.7 and raise it to an 8, right? And then T2 is equal to T2 minus 0.1. That would lower the value. They ought to be the same after that's done, right? They should both be 0.8. Are they the same? I don't know. So we're going to type in double difference is equal to T1 minus T2, and we're going to print that difference out. If they're the same, then it's going to print 0. That'll be the last thing that we see in our output. Let's see if they are the same. I have syntax errors of stuff that I was typing in further down. Sorry, there we have to correct that. Alrighty, check it out. It said that that's the difference between them. That's a very small number. That's a point followed by 15 zeros and then a 1. But it thinks that these are two different values, even though 0.7 plus 1 is equal to 0.8. And then 0.9 minus 0.1 is equal to 0.8. And why are there rounding errors? Because this stuff gets converted into binary values in order to be stored. And it means that one of these things could not be stored precisely as a binary value. And I'm not sure which one it is. Is it 0.7? Is it 0.9? One of those two cannot be stored as a binary value. And so when it did some math in it, we had some kind of rounding error. So just stuffing everything into a floating point value. Yeah, this would have done the same thing if I'd used floats rather than doubles. Just stuffing everything into a floating point variable so that you don't have to worry about integer division would not be a good idea if you need values to be spot on integers. If something needs to be an integer, really use it as an integer. I don't know if I totally answered your question. I'm hoping we will hit the point of floating point rounding errors again at a later point in the class. Did I get there? Sort of? Alrighty. So if you have two different operand types, if you do 13 divided by 2.0, this is an int. That's a float. It's a double, actually. When it's known as a mixed expression. A mixed expression is when you have two different operand types. So what happens is Java, the virtual machine, temporarily promotes the less complex type to the bigger type so that it matches this one. So what happens? Which is the less complex type, an int or a double? Ints are the less complex type. They don't have any floating point numbers and they're smaller. So this one gets converted into a double for that division to work. So division does what it calls grade school division and generates a quotient. 9 divided by 2. These are both integers though, so what's the answer going to be? 4. Yeah, 9 divided by 2 is 4. What if you care about what was left over? That's when you use percent. That's when you use modulus. 9 modulus 2 means 9 divided by 2, and what's the remainder? And the remainder of 9 divided by 2, you got 4 with 1 left over. So 9 modulus 2 is 1. 5 modulus 15 is, well, 5 divided by 15 would be 0, right? And then what was left over? So what's 5 divided by 15 if it gets rounded down? Help me out, guys. Yeah, that's 0. So then, what was left over? 5. 5 was left over, right? So 5 modulus 15 is equal to 5. Hope y'all already have the idea of modulus. This should not be your first programming course, and you know what modulus and remainder do. If you do, ask me for help. Google it up, read the text. Okay, this is wanting us to practice expression evaluation using PEMDAS and integer rounding. So let's take a look at it. Using the operator precedence table, we know that addition and division, or addition and subtraction, happen after division and multiplication are done. So let's take this thing apart one at a time. What do we have to do first? Parentheses stuff happens first. So we're going to do that first. So inside there, what's the first thing that's going to be done? The addition or the division? Division gets done first. So the x is an integer, y is an integer, so it's going to do integer division, meaning it rounds down. So 10 divided by 4, rounded down, is what?
2.
Yep, 2. So then we have 10 plus 2. We're still inside the parentheses. We got to do that first. Now we don't have any addition or subtraction to worry about anymore, so we just go left to right. What's 8 divided by 10? Well, these are still both integers, right? So it's going to do more integer division. So what's 8 divided by 10 rounded down? I think I heard it.
0.
Yeah, it's 0. And so what's 0 times 2?
0.
0. It's pretty strange that this complex expression here, I think I goofed something.
It's 12, not 10.
It's supposed to be 12
Yeah.
for z plus x.
Let me fill in all these variables again because I'm not.
You had 8 instead of 12.
All right. So 10 divided by 4 was 2. 6.0 plus 2 is 8.0. 8.0 divided by 10, these are now no longer both integers. So it's not going to round down. So what's 8 divided by 10 without rounding down?
1.
8 divided by 10 is 0.8, right?
Or
And then 0.8 times 2 is 1.6. If they had all been integers, though, then the answer would have been 0, as I think. I'm not going to calculate it a third time. I think that would belabor that point too. Alrighty. The increment and the decrement operators. You C++ programmers have seen this. You Python programmers have not. You can use plus plus to add a value to a variable. X plus plus is the same as writing x equals x plus 1. X minus minus is the same as writing x equals x minus 1. That's called increment. That's called decrement. Why are there special symbols for it? Because you do that so often in programming that they may as well make a simple symbol for it. You add 1 to values so often that it's nice just to be able to type x plus plus or x minus minus. The other way to do that is to say x plus equals 1. That copies 1 in. That adds 1 to x and then stores it back into x. Does the same thing as plus plus. So that's why the Python developers didn't even support plus plus, because you could just use that. But I like seeing plus plus and minus minus. I think it's cleaner.
That x plus equals is a bit confusing. I just prefer to do x equals x plus whatever.
Right, right. So you write it in a way that makes it look the clearest to you. If you want to write x is equal to x plus 1, you have 3 choices. You could write x equals x plus 1, or you could write x plus equals 1, or you could write x plus plus. Whichever one looks cleanest to you is the one that you want to use.
Does it support like x plus plus and then another number? Or is x plus plus always just plus 1?
If you did this, x plus plus and then another number, like a 5 there, it would count that as a syntax error. The reason why is it would translate it like this. It would say x equals x plus 1 in parentheses 4, like that. It's just, it wouldn't know what to do with it. So if there is going to be a plus plus, it's going to be alone like that. That doesn't mean you can't do this. A let's do A is equal to 0, B is equal to 2, B plus plus, and then C is equal to A plus B, and then D is equal to A plus 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 B. And then we're going to keep track of, I think I made too many of these, but if we were going to keep track of all these variables, A, B, C, and D, A is equal to 0, right? That's what that one says. Then what does B get set to? 2. And then what happens? We get to that line of code. What happens to B? It increments, so it becomes 3. And now C is equal to A plus B. So what is C equal to? Now D is equal to A plus 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 B. Now, the behavior of plus plus differs based on whether it comes before or after the variable. Since it came after the variable, the incrementing doesn't happen until the rest of the expression is done. So A gets added to B, which is 3. That gets stored into D, and then this goes up 1. Weird but true. So plus plus A means increment A before you do anything else. A plus plus means increment A after you do everything else. And if it's on a line by itself, it doesn't matter. Right? If you just have A plus plus, it doesn't really matter whether, it was added on before or after everything else, because there is no everything else. But if you do this, A is equal to 3, B is equal to A plus plus, or you do A is equal to 3, B is equal to plus plus A. Plus plus here means that it's the last thing that happens. So what is B going to equal when we're done? It's going to equal 3, because that gets copied over here. So B is equal to 3, and then A becomes 4 because we added 1 to it. On the other hand, plus plus in front of the variable means do that right away, lickety split. So A is equal to 3. This gets changed immediately to 4. And so B gets copied. 4 gets copied into B. So by the time we're done here, B is equal to 4, and A is equal to 4. Just remember that if the plus plus follows a variable, it's the last thing that happens in this statement. If the plus plus precedes a variable, that's the first thing that happens. I think we're about done with that. I know that we didn't actually write much of a functional program, but at least hopefully burn some of it in. Let's see if we have any homework assignments that would be reasonable to give at this time based on where we are. I think we gave one last week, right? Thursday, chapter 2. Make one up. Write a program that sets x to 10 and then does the following things to 10. Add 20 to x. Multiply x by 10. So add 20 to x and store into x. Multiply x by 10 and store into x. Increment x again. Decrement x. Print out x. That's all it needs to do. So how are you going to add 20 to x and store into x? That one's pretty easy. X equals x plus 20, right? Or if you like doing x plus equals 20, that also works. Multiply x by 10 and store into x. X equals x what? We're multiplying it by 10. Come on, guys. We want to get out of here. You could do that, or you could do x times equals 10. These are what are known as compound operators. Does two things at once. Multiplies it by 10 and stores it back into itself. You know how to increment, you know how to decrement, you know, so you ought to be able to do that. That makes sense, guys? I mean, it's going to be like a 2-minute program to write. It's not real rigorous. Not all of our homework is going to be 2-minute programs, I promise. Guess that was actually homework 4. So let's make a Dropbox so you can put your .java file in there. It'll be E September 7, Chapter 2. All right, refresh your Dropbox and you'll see E there. And homework 4 is due Wednesday at midnight.